All right, guys, welcome back. We are still on topic 4, rate of change, and we are on student activity sheet 2. If you remember correctly, we already completed the first part of it up through question 5 and then 6 through 9 where you reinforce questions. We are still on that, and we are starting at question 10. Okay, so to go along with question 10, okay, we're going to look at this pool problem over here. We looked at rates of elevators before, and they're going up, down, positive floors versus going down being negative floors. Now we're going to look at a pool. Okay, so every autumn, the Marino Community Center drains all the water from its swimming pool. So let's take a look at this animation to see how the volume of water, so the total amount of water in the pool, changes over time. So we can see that after 0 hours, meaning at the start time, there's 1,200 gallons of water in the pool. After 2 hours, there's 900. 4 hours, 600. 6 hours, there's 300 gallons of water. And in 8 hours, it is totally empty. Okay. So I want you guys to think, how did the volume of water change in the pool over time? Did the pool drain at a steady or a constant rate? Okay. Meaning steady and constant mean the same thing, guys, meaning that it's either as time goes on, it's going increasing or decreasing at the same rate. Okay. Meaning if I'm driving 55 miles per hour for this stretch, that means the next stretch I'm also driving 55 miles per hour, not going 30 to 60 to 20 like some of our speed demon crazy drivers out there. Okay, so for this first part, I'm going to go ahead and fill in my table here. Okay, I did exactly what they did. Okay, and I want us to think if the table had a steady or constant flow. So what I'm going to do here, guys, is I'm going to look at each of my increments. Okay, I see how much time changed between 0 and 2. That would be 2 hours. Between 2 and 4 was also 2 hours. Between 4 and 6 was 2 hours. And between 6 and 8 is 2 hours. Over here, I want you to be careful with this. Okay, the volume of water in the pool, it went from 1,200 gallons right here down to 900. Because it's going down, we're going to put a negative. And then 1,200 minus 900 is 300. Same thing, it went down 300 gallons. Whoops. It went down 300 gallons, and it went down 300 gallons. So with that, I want us to think about it. What was the rate of change for each time period? Okay. What is the rate of change for each time period? Okay. So what I want us to think about is that the pool loses 300 gallons of water every 2 hours. Okay. It's going down 300 gallons every 2 hours. So what I'm going to do is I'm going to come over here and I'm going to say my rate is negative 300 gallons over 2 hours. And then we need to simplify that. We can simplify that. So let's go ahead and show this. For 0 to 2, it was negative 300 in 2 hours. How does that simplify? Negative 300 divided by 2 is negative 150 gallons per hour. And I have that noted here. Okay. We can do that for each of these. From 2 to 4 hours, that's negative 300 gallons in the course of 2 hours, which equals negative 150. From 4 to 6, it went down 300 gallons in the course of 2 hours, which equals negative 150 gallons per hour. And again, between 6 and 8, it went down 300 gallons in the course of 2 hours, which makes it negative 150. Because all of these are the same, because each change of rate is the same, then we can say that it is constant. Okay. And again, there's my work showing the same thing that they show on the screen. Okay. So looking at that information, considering the previous questions, okay, what do we notice about all of these ratios? Okay. First, I want to go back and I want to talk about what does this negative 150 gallons mean? Okay. In this case, the negative 300 gallons for every 2 hours, it was the same in each case. And again, that equaled negative 150 gallons per 1 hour. So what does it indicate about the rate of change? I apologize, guys, for the break here. I had a teacher come in and to ask me a question. So again, they want to know what does this indicate about the rate of change? What this means is that my rate is negative 150 gallons in 1 hour. But what does the negative 150 mean? What that means is that the pool is losing 150 gallons every hour that goes by. Okay, so the pool is losing 150 gallons every single hour. The rate of change for the amount of water in the swimming pool is negative. Does that make sense in this situation? What would be happening if the volume were positive? Okay, so because the pool is losing 150 gallons of each hour, the negative number makes sense because it's going down. Now, for positive, if the water level was going up, if my water level was, we'll use this, was getting higher and higher and higher in my pool, that means that it would have a positive fill rate. Okay, so it would be positive if the volume were going up. Okay, so let's go on to the next question here. So again, that was my last two questions, 15A and B. Let's go ahead and turn the page. So again, we said that the negative rate makes sense because the water in the pool is decreasing, draining. If it were positive, that would indicate the amount of water in the pool is increasing. The pool is filling up. Okay. So what they want us to do here, guys, I want to make a graph of what this information looks like. So let's show at 0 hours. So here's 0 hours. How much water is in the pool? 1,200. So at 0 hours, the pool has 1,200 gallons. At the 2 hour mark, so I'm going to come over to the 2 hour mark, it goes up to 900 gallons. At the 4 hour mark, it's at 600. At the 6 hour mark, it's at 300. And at the 8 hour mark, it is at 0. It's empty. Let's check that. We're good. So go ahead and put that on your graph here. Okay. And let's think about this next question. If the rate of change for the pool were positive, would the graph rise or fall from left to right? Okay. So when it was negative, when my graph was negative, it fell from left to right. Okay, negative means that it falls from left to right. Okay, it works downwards. Okay, but if it was positive, meaning we'd start with a low number of water, don't put this on your graph, but I'm going to draw it just so you can see it. Say we started with 0 gallons. We'd be down here, and after 2 hours, there was 300 gallons in the pool. And after 4 hours, there was 600 gallons in the pool. So you guys can see that it would be rising. Okay. So if it's positive, if it's filling, my graph is going to rise from left to right. So let's go ahead. Again, I wrote it would rise from left to right if it was positive. Okay, so let's do another example. So we've got Lewis is on his high school baseball team. They're going to raise money for next year's uniforms. So in order to do that, they're going to sell baseball camps. So this table here shows us the amount of money that they'd make depending on the number of caps sold. Okay, so the first thing they want us to do is to find the difference of the dependent variable. So remember, dependent means the total. So we're looking at the total money collected. So I'm going to go through here. What I did is I said the difference from 0 to 10 was plus 10. From 10 to 30, it was plus 20. From 30 to 50, it was plus 20. From 50 to 60, it was plus 10. And from 60 to 90, it was plus 10. Well, that doesn't look very constant to me. But let's just keep going here. Okay, so again, we just said $10, $10, $20, $20 again, $10, and $30. Okay, so now let's do it for our baseball caps. Okay, from 0 to 1, that's 1 hat sold. From 1 to 3, that's 2 hats. From 3 to 5, that's 2 hats. From 5 to 6, it's 1 hat. And from 6 to 9, that's 3 hats sold. Okay, so now what is the ratio of the amount collected, the amount collected, the total amount collected to the number of caps sold in each case? So to do that, what we're going to do is we're going to set up a ratio over here. So from $10, we sold 1 cap. So I did 10 to 1, and that equals 10. From 20 to 2, if I divide that out, that was 10. From 30 to 3, that equaled again 10. So while it didn't look like it was constant, either on our independent variables or our dependent, if we divided it out, they had the same rate. Each cap made $10. It was $10 per cap. Okay, so now what I want to talk about here, in the in the baseball cap situation, okay, we talked about the different differences here. We had the pool that went down by 300 gallons per 2 hours, okay, and then we had the baseball cap that while they had different differences, they were still the same number. Because these were differences between just one level of items, we call these the first differences. Again, just the difference between the top and bottom of each level are considered the first differences. Okay, so go ahead and write that down if you need to. I'm going to put it down off to the side here. First differences. First differences. What are the first differences? They are the differences in corresponding values of the independent and dependent variables. Okay. So here we are on question 19. Okay. They want to know if we can solve this puzzle. We have a stationary bike that we're going to measure the number of calories we burn depending on the number of minutes we pedal. So let's just take a look at this. Okay. From 0 to 15, the change is 15. From 15 to 30, that first difference there again is 15. From 30 to 45, that's a difference of 15. And from 45 to 60, it's a difference of 15. But now let's go down here. From 0 to 105, that's 105. 105 to 210 is 105. 105 from 210 to 115, and 105 from 315 to 420. Okay, so let's think about this. I want to know what the rate of calories per minute. So because they call it calories per minute, we're going to take the calories first. On top, 105, and the minutes on the bottom, 15. And if we divide that out, we're seeing how many times 15 can go into 105. We can go through a simplifying process, but if we use the calculator, we find that that's the same as 7 calories in 1 minute. So let's go ahead and drag that down. Okay. And that should be on your question 19 here. Okay, so then let's go on to question 20. So now we're back to the baseball cap situation. Okay, we're gonna go through this graph here to see what information we can find out. So they wanna know, what would the graphs of the data from the baseball cap and bicycle workout situations look like? So let's do the baseball cap first, okay? For 0 caps, we made 0 money. When we sold 1 cap, we made $10. So 1 cap is $10. 3 caps is 30. So 3 goes up 10, 20, 30. 5 caps was 50. 6 caps was 60. 9 caps was 90. Okay. So now let's do, if you want to go ahead and put that on your paper. Okay, so now what we're going to do is we're going to go through and do the bicycle. Maybe. Okay, so the bicycle, again, they did 0 time for 0 calories. So 0 and 0. After 15 minutes, so that's about halfway there, we burned 105 calories. After 30 minutes, we burned 210 calories. After 45 minutes, we burned 315 calories. And after 6 minutes, we burned 420. Okay, now again, those are approximate numbers there because there was not real specific on my graph. Let's check that. And it looks like it's good. So let's go ahead and get that on our paper. So now let's compare the two graphs, okay? What do they both have in common? What do they both have in common? Okay, so I see that they both fall on a line. If you notice, they have a line. I could draw it in Imagine if I wanted to. I don't know if this will let me. I could, whoa, that's a little off, I'd say. Never mind, I just won't use that feature. Okay, so I'm gonna go back to my mouse here. Again, you can see they fall on a line. Both of them do. Okay, so again, the points fall on a line. Okay, because of these situations, if we look at all of these, we've got nice lines here, lines, 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 okay? This is what we call a linear function. When we have a straight line, okay, a linear function is a straight line. What that means is that our rate of change is constant. It has a constant rate of change. And that is it for this section. We have, now it's going to seem like a lot again, guys. It's going to seem like a lot. Question 21 takes up a couple pages just because graphs take up so much room. So question 21, A, B, C, and D. Question 22 and question 23, please. And then your teachers will go over this with you. Ooh, that got a little blurry. Your teachers will go over that with you.